The aim of this experiment is to determine whether or not human processing of macadamia nuts leave behind specific features that can be used to identify prehistoric subsistence patterns in the archaeological record. I will be testing a combination of 3 variables of human processing techniques to determine if these have an effect on the fracture patterns of macadamia nuts and whether the frequency of these fractures could be used as diagnostic criteria to determine the processing methods used archaeologically. If this is the case, then through the analysis of past human subsistence remains, archaeologists will be able to determine which methods were used to process macadamia nuts in the past. This project is an adaptation of Britt Asmussen's experiment on the identification and application of experimentally defined correlates of Macadamia seed processing. In her work, Asmussen investigated the fracture shapes of cycad nuts caused by various human processing variables, and whether the frequency of these fractures could be used as diagnostic criteria of what processing methods were used archaeologically. To this date, no work on the fracture patterns of processed macadamia nuts has been published, and it is difficult to find published information on prehistoric nut remains found within the archaeological record of Australia. Macadamia trees, however, are a native to Australia, and these nuts would have most certainly been exploited for food in the past. If diagnostic fracture patterns can be determined, then the results of this experiment could be very valuable to the archaeological community by providing a small reference collection for use in analysing the processing techniques of prehistoric macadamia nut remains found within the Australian archaeological record. This experiment tested the effects of 3 variables. Firstly, if striking the nut with a hammerstone causes different fractures to that of a wooden batten. Secondly, whether striking the nut at the attachment end or on its side consistently causes fractures of specific shapes. And thirdly, whether thermally modifying the nuts through heat treatment prior to cracking has an effect on the ease of cracking or the resulting fracture shapes. Combinations of each variable were tested on multiple nuts, allowing 4 nuts for each experimental set. The materials used were as follows. For the anvil, I used a river stone measuring 16 by 11 centimeters and weighed around 1.8 kilograms. This had a reasonably concave platform to help keep the nut in place. There were 2 indenter types used. The hammerstone consisted of a river stone measuring 13 by 11 centimeters and weighing just under a kilogram. The wooden batten was made of a large piece of pine dowling, measuring 40 centimeters long, 4.5 centimeters in diameter, and weighing 400 grams. I used 32 macadamia nuts with sizes varying from 24 to 28 millimeters in diameter and weighing from 7 to 12 grams each. A number of controls were set in place for this experiment. To keep the results accurate, when numbering the nuts for each experimental set, a combination of small and large nuts were chosen so that each set had nuts of similar sizes and weight. Each nut was checked for damage, and although all the nuts had cracks due to natural drying processes, only undamaged nuts with fine cracks were used. All thermally modified nuts were heated for the same amount of time and were placed at the same distance from the coals. While conducting the experiment, all nuts were held with my left hand and struck with my right, and a similar force was used for each strike. I began each strike from a predetermined starting point, which kept the height and angle of the strike at a constant. Each nut was struck on the same spot, either at the attachment end or at a predetermined point on the side. I began the experiment by weighing, sorting and numbering all the nuts in advance. I then thermally modified half the nuts. This was done on a charcoal barbecue rather than any other method to more closely simulate the hot coals of a natural fire. To ensure the nut inside did not burn, each batch was placed in the coals for 10 minutes. Once cooled, I struck the nuts on the anvil using the various methods. I began with the hammerstone. The weight of the stone proved very successful in breaking the nut, however one of these nuts could not be broken within 30 strikes. I then moved on to the wooden batten. The batten, being lighter and more tender than the stone, was not as successful, and as a result, 6 of the 16 nuts could not be broken within 30 strikes. During the experiment, all data was recorded on a spreadsheet for further analysis. I recorded the number of strikes to fracture the nut, the number of fractured pieces, and whether the nut was removed in one or more pieces. After the experiment, all nuts were examined and photographed for fracture shapes and patterns. First, I analysed the number of pieces of fractured nut resulting from strikes of different variables. I began with the nuts that were struck by the hammerstone in comparison to the wooden batten. These results showed the hammerstone, on average, shattered the nut into more pieces than that of the wooden batten. However, these differences are very marginal. It is also notable that 7 of the 32 nuts did not break within 30 strikes, and nearly all of these were struck by the wooden batten. Next, I analysed the fractured pieces of thermally modified nuts as compared to non-thermally modified. Again, the differences were marginal, with the thermally modified nuts on average shattering into more pieces than those non-thermally modified. Finally, I analysed the amount of fractured pieces caused by striking the nut at the attachment end or on its side. The results were more noticeable in this case, with strikes on the attachment end causing more fractured pieces than those struck on the side. After analysing this data, it must be concluded that there is insufficient variations between the data sets to determine if the variables of this experiment have a significant effect on the resulting number of fractured pieces. The next step was to study the fracture patterns left behind on nuts within the different variables. Each nutshell was examined and recorded for a fracture frequency analysis. Within the results, some patterns were discovered. Out of the 32 nuts struck in the experiment, 7 did not break. 6 of those were struck by the wooden batten, whereas only 1 was struck with the hammerstone. Also, out of the 10 nuts struck by the wooden batten, all had crushing on either the impact point or the point resting on the anvil. In comparison, only 1/3 of nuts struck by the hammerstone had crushing fractures. 1/3 of the hammerstone nuts had ring cracks, mostly at the impact point, and of these 5, 4 were thermally modified. Only 2 nuts struck by the wooden batten received the same fracture. Once the experiment was completed, the hammerstone and anvil both showed signs of use wear in the form of polish on the points of impact. The wooden batten also showed signs of use wear through indentations in the wood. However, these would not normally survive archaeologically. Through the analysis of these results, it is evident that there are no fracture patterns that are diagnostic of one particular variable or set of variables. It is evident, however, that the wooden batten created more crushing fractures than the hammerstone. Therefore, through lack of crushing features, archaeologists may be able to determine if nut remains were struck using a hammerstone. All other diagnostic data collected in this experiment cannot be used as diagnostic criteria for analyses of archaeological remains. However, they may be used through the probabilities of fracture patterns to estimate what processing methods may have been used archaeologically. This experiment was conducted to determine if human processing techniques have an effect on the fracture patterns of macadamia nuts, and whether the frequency of these fractures could be used as diagnostic criteria to determine the processing methods used archaeologically. Through this experiment, it is evident that human processing of macadamia nuts leaves specific fracture patterns that can be identified in the archaeological record. However, these patterns cannot tell us whether the nuts were thermally modified or on which part they were struck. The lack of crushing on the impact area or resting point can most likely point to a hammerstone rather than a wooden batten being used on a stone anvil. A very small sample size of macadamia nuts were used in this experiment, and therefore I advise further experimentation with larger sample sizes to be conducted for a more detailed analysis of macadamia nut processing methods.